Many people still have many analog AC or DC locomotives lying around and would like to run them on the digital DCC layout. If you can't do the conversion yourself, it can quickly become expensive. This tutorial shows you the installation of a decoder in a HAG AC locomotive without interface. For DC locomotives, the steps are almost the same and actually much easier. I will mention the difference. The first thing is to check if the locomotive runs properly. To do this, run it on a test track. In this case, everything runs cleanly. If it's not the case, you have to repair it first. The next step is to open the housing. Then remove all the wires and the light bulbs. Then remove the direction switch. The retaining screw is kept. Then remove the drive bogie. For the conversion to DCC, it is necessary to convert the AC motor to a DC motor. DC already have such a motor, and so the next step are not necessary. First, remove any chokes and capacitors. Then remove the brushes, the motor shield and the armature. The brushes will be used again later. If they are worn, then they should be replaced before reassembly. Now remove the stator. You have to use a lot of force to get it off. Now it is all in pieces, so you should clean everything properly. There are oil residues as well as carbon dust from the one brush. You should not spare with chemicals to get rid of everything. Then oil the gears inside the engine. Now comes the installation of the permanent magnet. In this case we use a HAG magnet that fits this locomotive. You really have to buy the right part, otherwise it won't work. There are also conversion kits where you can mount a new 5-pole armature as well as a motor shield. This improves the driving characteristic. In this case we continue to use the same motor shield. Some manufacturers have connections between the shield and the housing, but this must be separated, otherwise the decoder will smoke. Also for this installation you have to work with a lot of force. After that the armature is reinstalled, then the motor shield is put on top and the whole thing is screwed together. Again, use a lot of force. Finally, put the brushes in place. They have to be placed the right way around. Then oil the whole thing with enough but not too much oil. Then solder a choke of approximately 6.8 microhenry to each terminal and a capacitor between the two terminals. This should have a value of about 1.5 nanofarad. Now test the whole thing by connecting it to a DC source. Run the motor in both directions at full speed. If it creaks, make sure that everything is firmly mounted. If not, lubricate very lightly. If everything runs smoothly, reinstall the bogie in the frame. From now on the steps are the same for an AC or DC locomotive. To simplify the installation of the decoder, an interface board is installed. This way the decoder can easily be exchanged in case of failure. We use a board from ISU. The board is maintained with a retaining screw and nuts where the direction switch used to be. This screw is now too long and has to be shortened. Now it is time for soldering. 8 wires have to be soldered. In order to keep the housing clear, you should use wires that are as thin as possible. The colors are prescribed by NRMA and NEM standards. There is also a märklin coding scheme, but this should only be used in märklin locomotives. The connection on the board can be found in the instructions manual. The board has connection on both sides. You should use the back side if possible. The decoder is on the front side. First solder a red cable from the pickup to the board. On a DC locomotive this is the one wheel side. Then solder a black cable from the ground point on the motor. On DC locomotive this is the other side. Then solder a orange cable to the choke on the left motor connection and a grey one to the right one. Now a test follows. First check with the multimeter that there are no short circuits, especially between the motor and the frame. If everything is okay, insert the decoder. Here we use a ISU Log Pilot 5. The decoder is recognized by the log programmer and then the locomotive can be run. Besides the housing, the locomotive is too light, so you have to push it slightly on the rails to make it run. Since the original light bulbs are gone, we replace them with LEDs. This saves electricity and the loco gets less warm. We use white warm LEDs. This needs a resistor. In this case 680 ohm. The exact value depends on the LED used. At the cutout, the negative pole, you connect a white cable to the front light and a yellow cable to the rear light. The front is where the pickup is and the back is where the motor. Solder a blue wire to the anodes, the positive pole. If you have exposed solder joint, you have to use heat shrink tubing to insulate them. After a test to make sure that everything is connected correctly, mount the LED in the holes of the bulbs. In this case they fit exactly. To mount the rear LED, the drive bogie has to be taken out again. Then we glue the LED in place with bonding UV glue. You can also use epoxy glue. Use as little as possible so you can take out the LEDs if necessary. Fix all cables lying around and screw the housing back on. Then you program the motor parameters, which you can find in the instruction manual. On the layout we use then the Pico measuring card to set the speed. On older HAG locomotive, the wheel spacing is narrow, so that the wheel can touch the center conductor at turnouts. Remedy is nail varnish on the inside of the wheels and under the pickup. If you want to run in double traction, the locomotive has to be adapted accordingly. This is why quite difficult with this new Roco locomotive with CMO decoders. During test runs, we noticed that the locomotive could not run a gradient with more than one car. The problem was due to the traction tire, which had aged extremely badly, so that the wheels slipped within the tires. When we removed them, some of the tires broke and the rest were no longer stretchable. Research on the net shows that märklin tyres should be used. On this loco, some with article number 7153 fit. After that, the locomotive drove up the gradient without any problems. As you can see, it's not a big deal to convert a locomotive. If you have any questions or comments, please write them in the comments below. If you like this video, please like it and subscribe to this channel.